Okay, we're gonna do figure 7 question 1a, and this problem can be quite tricky because even though it looks pretty simple, but it helps us get used to the idea of sketching in Inventor. Okay, although it's very similar to AutoCAD, there are some subtle differences between the two. Okay, the commands learned will be how to add dimensions to the lines and the angles. Then we'll be drawing a point. Then we have a mirror function. Use the mirror function within the sketch. And the last is the whole function. Okay, so what I'll do is I'll create a sketch first on the exact plane. I'll rotate by the top. First I'll draw the, whoops, I think I accidentally control Z. Top. First I'll draw a line, the mirror line. Okay, which seems quite long. I don't need it to be that long. Yep, over there. And then I will draw the circle, maybe about there. And then I'll draw a line. I'll draw it a little longer. And the distance of that line to the horizontal is 10 millimeters. Okay, I'm going to enlarge the radius of my circle. And then there is going to be a angle here that is 60 degrees. Okay, and I can trim it so that what happens is that there is a point over here, and this point is the point where uh, I can use this coincident constraint to constrain the edge of the circle to this point. So I'm going to zoom in, and it's this point over here. Okay, so you have to be careful about it, because if you don't, it may constrain to the midpoint, which is very close to this. Okay, so we want to avoid that, right? Then I'll trim this away. I don't need this. Don't need this. I can put a radius on it. Okay, so I'm going to trim it along the way so that it's not so messy, right? And the next thing I want to do is add a point somewhere around here, and I'm going to constrain it horizontally on this axis. Then I will add a dimension to it, and the dimension is 58 millimeters. Wow, so close. Now I'll draw my first circle, and the first circle is R24. Alright, where did I get this R24? Is this R24 here? And because I'm drawing it in the, I'm going to dimension it as a diameter, it will be 48. Okay, so this will be diameter 48. All right, then I'm going to create another point, which is somewhere here, and the distance of this point to this point here is 18 millimeters, and the height of this point to this point is 24 millimeters. Right, where did I get a 24 millimeters? Again, it's from the drawing. Right, I'm drawing this point over here, and from the center is 24 millimeters. So once I have this point, I can create the radius that's at the top, the one that says R14, and that radius will give the diameter as 28. Okay, now that I have two circles, I'm going to draw the arc that is tangent to both of them. Okay, and the arc is rather large, right? And the diameter of the arc is 148. Okay, 148. Enter. And this arc is tangent to the large circle, and this arc is also tangent to the small circle. Okay, so once that's done, I'll do some of my trimming so that it doesn't get overly messy. All right. I won't trim this part yet. I may trim this. Ah, okay. And some of my dimensions are gone because after the trimming, so I'll just add it back in, right? So that is constraint. And this one is 48, 48 to create this. Then I know I'll just add a dimension of this to this. It's constraint. Then the other thing is a horizontal line that is from here all the way up. Okay, and this is 90 degrees. All right, I can add a perpendicular constraint. I think it's already there. So once a constraint is there, if you try and add another constraint to it, it will over constrain, and they will tell you that it's over constrained, so you can't do that. Okay, but what I'm going to do is I'm going to put this line tangent to this circle here. Okay, then that fully constrains it, and I can trim it away. All right, instead of using trim, I can just highlight all this, delete this. I accidentally deleted my dimension. Control Z. It's from here to my this point, and it's 18 millimeters. Then this is my radius, and I lost my earlier arc, which was 24 to this. Okay. Twenty-four to yes. Okay, I'm trying to fully constrain the large diameter. All right. So I have this arc that's constrained. Then I need to draw a fillet, and the fillet is 5 millimeters. So you can enter 5, and then you put your fillet radius here. Okay, fillet radius here. Now once that is done, yes, because my distance here was deleted earlier on. Okay, and this is half of the profile. And what I can do is I can mirror within the sketch option. And the mirror line is here. Select the mirror line, it's here, apply, and I'll have the whole profile out. Okay, then I can press finish sketch, and I can extrude the part out, and the thickness of it is 12 millimeters. Okay, the profile is selected, it's 12 millimeters, extruded up, click OK. All right, now to create a hole, you could actually just draw a circle, right? Draw a hole, and then the diameter of that hole is diameter 25. Is that 25? Can I see it? 25? Yes, it's 25. And that's one way of creating it. All right, extrude, cut, through all, right? But however, this method of creating a hole is not allowed for this particular module, although you can technically still do it. But if you were to draw holes like this without the hole command, which I'm going to teach later, you will lose your marks, because by drawing holes like this, you do not allow the designer to make modifications to the type of hole, the features of the hole, so that creates a lot of inefficiency problems. Okay, so how do you go about creating holes the correct way for this particular module? You create a sketch, okay, and then you specify your points. Okay, and this is your point over here, right? And once that point is done, that hole is done, I could draw 2 points, right? I could draw, but I'm just going to draw one to create one hole first, right? And you use the hole command. Okay, the hole command allows you to choose the different types of holes. You can choose threaded holes, countersunk holes. You can have different kind of counter bore, right? Or countersunk features. Okay, but for now, we are using a straight hole diameter, and the diameter of the hole is 12 millimeters. Okay, so I'm going to just put there 12, and this is the diameter of the hole. Right now, I could draw 2 points here. So what I do is I can edit sketch, and I can add the second point. Right, I move my mouse to the outer radius here, and the center is shows up for me to click on it. Okay, and if I were to use the hole command, it will automatically pick out the 2 points that I've created and create the holes for me of diameter 12. All right. Now let's say I didn't do this. Let's say I delete edit sketch. Let's say I delete this hole and I've only got one hole. And to create the other hole, what you can do is you can use the mirror as well. So the mirror command exists both in the 2D sketch plane and in the 3D. Okay. Now, it is best if you keep your 2D sketch simple. Okay. In my opinion, I would consider this a complex 2D sketch, right? But keep it as simple as you can, and then you add features and you do your modeling at the feature level instead, and then less mistakes would arise from there. Okay, so what I do is I select the feature, and the feature is this hole, and the mirror plane, I go to my work planes. Okay, my exact plane, and because I drew everything symmetrical to the planes, to the 0 point, I can choose this as my mirror plane, and I click OK, and this hole gets created. Right now, if I were to change the diameter of the hole, edit feature, right, and let's say I change it to let's make it really drastic so that it's very visible, a 3 millimeter hole, and when I click OK, it will update itself, right, and it will update itself, and it will rebuild the mirrored feature. Okay, so everything is related, interconnected, and everything will update by itself. So if you make a mistake somewhere in the front, and if it rebuilds, or you make a mistake somewhere down the stream, and if it rebuilds, it could cause and create errors. So here's how I go about doing it. I edit feature, and so how do you minimize these errors? Well, you minimize errors by ensuring that your sketches are fully constrained, and you minimize errors when you are clear about your design and design intent, so that when you draw, uh, it will not build or cut in thin air, and that will cause an error. All right. So this is part figure 7 question 1a. See you again soon.